Good morning everyone. Today we will talk about rubber. Rubber, chemically it is called polyisoprene unit. Rubber is obtained from the rubber tree and it is obtained in the form of colloidal suspension of rubber in water, and that is called latex. Chemically it is the polymer of isoprene unit. What is isoprene? 2-methyl buta-1,3-diene is called isoprene. Now this will polymerize to give the natural rubber, which is polyisoprene unit. Polyisoprene. Remember, a natural rubber is a cis polymer of isoprene unit. So how to make this cis polymer? First of all, this double bond will be shifted here, and again this double bond will further shift. So as a result, the position will be somewhat like this: CH2, C, CH3, double bond here, then we have CH, and here we have CH2. So we have to now write these molecules, means we can repeat these molecules. So here when we repeat these molecules, we will get, I have written here 3 molecules. Now these 3 molecules, these are the cis products. See, similar groups are on the same side. These will be attached with each other. Through CH2, they will attach. This will lead to the cross links. So natural rubber is a cis polymer of isoprene unit. So it's a cis polymer of isoprene unit. If it will be trans polymer, then it is called gatta parcha. Gatta parcha. Now after that, what are the why rubber is so elastic? The high elasticity of natural rubber is due to the absence of polar group and the cis configuration about the double bonds. So what happens? Due to cis configuration, these molecules, they cannot come much closer to each other. So that's why it makes them highly stretchable like springs or other elastic molecules. Now rubber cannot be used at a wider range. It has got some limitations. It can be used in a temperature range of 283 to 335 Kelvin only. Now if we try to use it at higher temperature, it becomes soft, and below this temperature it becomes very brittle. Now in order to make rubber more usable, what we do, we perform vulcanization of the rubber. Vulcanization of rubber. What is vulcanization of rubber now? That is treating the rubber with this sulfur in the presence of zinc oxide or carbon black at a temperature range of 373 to 415 Kelvin. So what happens when we heat rubber in the presence of sulfur? Means basically sulfur will be adding the linkage, the cross links between the various monomers. So sulfur, and the reaction takes place in the presence of zinc oxide. So then we get the vulcanized rubber. Vulcanized rubber. Now this vulcanized rubber, basically where this sulfur will be added. This sulfur will be added either at the allylic positions or at the double bond. See how this will be added this way. This is the first molecule, CH2, C, CH3, CH, CH2. Now this can be polymerized both the sides, and this is another chain, CH2, C, CH3, CH, CH2. Earlier here was double bond. Here was also double bond. Now instead of double bond, I have connected them through this sulfur linkage. So here sulfur has been added at the double bond. It can be at the allylic position also. See how this CH2, C, CH3, double bond CH, CH2, CH. Obviously I need to write here CH2, but I am not writing here. CH double bond CH3 CH2. this can be elongated. Now one of the hydrogen from here will be removed, and this carbon will connect with this carbon through this sulfur. That's why I didn't write here 2. So here the 2 chains have been connected through this sulfur linkage. So sulfur can be added either at the allylic position or at the double bond. Now after this, what are the properties? Now why do we add sulfur? By adding sulfur, because of these cross links, stiffness is introduced. Due to the stiffness, the properties and the uses of the vulcanized rubber varies. Now extent of stiffness depends upon the amount of the sulfur. For example, if we add sulfur about 5% of the sulfur, 1 to 5% if we add, then it can be used in the formation of rubber. Which rubber? Rubber tires. Rubber tires. But if we add 3 to 10%, definitely more the sulfur, harder the rubber will be. And if we add 3 to 10% of the sulfur, then here we are using it to make hard rubber. But definitely, if this percentage further increases and it becomes up to 30%, means 20 to 30% sulfur, then it will be used in the form of plastic. That is, our batteries we are using at our home, they contain 20 to 30% of sulfur. So it becomes very hard rubber, which can be used as a plastic. So what are the properties of vulcanized rubber? Properties of vulcanized rubber, or how vulcanized rubber is better than the natural rubber. It is hard and non-sticky. It is not oxidized readily and exhibit the same behavior in all weathers. Neither becomes sticky nor becomes very hard. Resistant to the attack of organic acids, and of course it is highly elastic, and that elasticity is maintained over a wider range of temperature. After this, let us come to the synthetic rubber. As the name suggests, synthetic rubber means we need to alter the properties of now the natural rubber by synthesizing synthetic rubbers. So what are the different synthetic rubbers? Very first synthetic rubber is neoprene. Neoprene. Now this neoprene, it is prepared by the polymerization of chloroprene. What is chloroprene? Chloroprene is 2-chloro-buta-1,3-diene. 2-chloro-buta-1,3-diene is called chloroprene. So and such monomers will polymerize to form the neoprene rubber. So this is neoprene. This double bond will be shifted here. As a result, this double bond will be further shifted. So we will get this type of polymer. So this is called neoprene rubber. So what are the properties and uses of neoprene rubber? The very first property is it is thermoplastic. Means it can be remolded. Thermoplastic. And of course it's a synthetic rubber. Though it is inferior to the natural rubber in some of its characteristics. But obviously it is superior in its stability to aerial oxidation and resistance to oils and gasolines. So that's why neoprene is used in the manufacture of containers for storing petrol, oil and other solvents, in making hoses, shoe heels and stoppers. It does not catch fire, so that's why neoprene belts are used in coal mines. Coming to now the another polymer, which is Buna-S rubber. Bu butadiene. Na means sodium and S means styrene. So it is a copolymer of 1,3-butadiene and styrene molecule. So it's a copolymer of buta-1,3-diene and styrene molecule. Now we have to take N such monomers and N such monomers in the presence of sodium. On heating, they will polymerize to give the polymer. Name of the polymer is Buna-S rubber. So this is the Buna-S rubber. Buna-S rubber. So what are the properties and the uses of this Buna-S rubber? Buna-S rubber is a synthetic polymer known as SBR, styrene butadiene rubber. It is quite tough, less tensile than natural rubber. Coming to its uses. Uses of Buna-S rubber are: it is used in the manufacturing of tires for automobiles, for making rubber soles, belts, hoses and tiles, floor tiles. Next is Buna-N rubber. As the name suggests, Buna, so it's a copolymer of butadiene and acrylonitrile, Buna-N rubber. Buna-N rubber. So first monomer is butadiene and the second monomer here is the acrylonitrile, CH double bond CH2 CN. Now in this case, this double bond will be shifted here, this double bond will come here, this double bond will further shift. Again, the reaction takes place in the presence of sodium. So what happens? It will be becoming CH2 single bond CH double bond CH single bond CH2. Then there was no bond, so due to migration of electron, bond will exist now. CH CN single bond CH2. So this is free, so this can be extended. So this is Buna-N rubber. Properties and uses of Buna-N. It is resistant to the action of petrol, lubricating oil and other solvents. So it is used in making oil seals and tank linings since it is inert towards the oil. Thank you.